Good afternoon, everyone. My name is Kyle Monahan. I'm the teaching fellow for the Water Health and Sustainable Development course here at the Harvard Summer School, and I am just going to go through tutorial 1 for you today. And as I am traveling, I just wanted to make sure that you have a complete walkthrough of what's expected. I'll go through some of the analysis with you to get you started and to get you a feel for what is expected here. As this is the first assignment, I know you might have some questions, so I'm also offering extensive office hours for you to use and ask questions if you have them. So the first assignment gives you the story of the city of Flint. And for those of you who may not know, the city of Flint was impacted by a water quality problem that came from the lead leaching from their pipes due to a change in the water source that was used. During this assignment, we ask about how you would sample to monitor and understand the environmental risk that this public health crisis imposes. It gives you the kind of general approach to what to think about, and we have some selected readings, so 4 total readings for you to go through and use to assess this essay question. And the essay question starts in the second paragraph. It asks, how will you sample? What methods will you use? And what will you tell the sampling scientist to pay attention to? List 2 chemical, political, and social influences which you'll have to take into account. And what are the key principles of water quality sampling that you should apply? Justify your statement. So in the rubric, and so for each assignment in this course, you'll be provided a rubric. And it goes through exactly how you will be graded on this work. So one of the things I always want to do for this course is make it very clear how you will be assessed so you can expect the type of response that you get. And so in this case, the first section is material use. We suggest you use at least one material from the course which add to the discussion. And that can be any one of the readings from the module section over here. So if I open this up, you can see the module section. Well, you normally can't see this section. Let me activate student view, actually. That's a good idea. So, well, I'll do that later. But so you'll go through the materials used. We'll then go through the influences listed, so 2 chemical, political, and social historical influences. We'll go through the length, so you'll want it to be at least 1 to 3 typed pages with citations included. Key principles, 2 suggested principles of sampling or monitoring were also included in decision. Now you may ask, how will I know the principles of sampling or monitoring? Well, you have 2 places to find this core material. One is in the readings, so if you read through these readings, they suggest different things that you'll need to account for. And 2 is in the video itself. So if I click on here, it will open up the DCE, Division of Continuing Education's video player, and you can click and you will see me talk.
Well, hello, everyone.
It's awkward to watch because it's me, but you will see me talk about the lecture and go through the entire process of working with the data. If you're wondering where to access the data, if you go back to modules and scroll down to class 2, you'll be able to see that data there. We'll make that available to you. So that will work well. All right. So, so the readings here, I just want to quickly go through. The first one is on the EPA memo on the Flint lead. So if we open this up, it is from Miguel del Toro, and it's summarizing the available information regarding the activities that were taken in response to the violations to specific regulations that occurred in 2014 in Flint, Michigan. So these include acute coliform and total trihalomethanes. Now these are normally associated with over-chlorination or under-filtering before chlorination, right? So that can lead to changes in the water chemistry. One of the main issues that occurred was that when the city of Flint switched from purchasing finished water from the city of Detroit to using the Flint River, the city of Flint is no longer providing corrosion control treatment. And we will talk a bit more about that But they mention in here that this is a huge problem, and it's very important for mitigating lead and copper levels. So that's a key thing to think about. Next paper, reading number 2. I'll save this here. Open it up. It's a review article, a special report on how to reduce lead poisoning in children. So lead poisoning, because of the lack of the developed blood-brain barrier in young children, can be a huge issue. And so you can read that to learn more about the health impacts. This is a systematic review by Dr. Gundry, Wright, and Conroy, published originally in Journal of Water and Health in 2004. And this is looking at household water quality in developing countries. So there are implications beyond just Flint for household water quality. And it is actually a whole field that you should have a general idea about. And there's a lot of work to be done there. The final paper is a EST, Environmental Science and Technology paper from 2017 by Pieper et al. And Mark Edwards, who is the lead author on this, was very active in the Flint water crisis. And so there's some interesting graphics here, but also a great amount of information about why, if you have a lack of corrosion control, it leads to lead becoming soluble in the water, destabilizing off those pipes, and mobilizing. This is the phrase they normally use. So becoming mobile in that water, and then therefore being a risk of exposure to people who may drink that water, of course, depending on the water chemistry. So this, in general, is all of the materials that you need to work through this. If you want to follow along and do the work that's mentioned in this video alongside, you're welcome to. As you can see in the rubric, you do not need to complete the workshop instructions and primer in order to complete the tutorial, but you are welcome to. So if you want to use the if you want to go through the workshop materials, you can, but you do not have to do that. So if you open this, you see it gives you information on the tutorial. It talks a little bit about sampling, data processing, some suggestions and general tips. It goes through data graphing and understanding the data set. Now note that this says Class 2 February 1. That's just there to match exactly what is shown in the video, but the actual Class 2 is, of course, not in February. But if you go to Files, Class 2, and you look for the Excel sheet that says Tutorial 1, that is the data. Now again, this is totally optional. It is not required to go through the workshop instructions and the optional reference video in order to get full credit on the essay question. But I found that students enjoy learning about how to do statistics on water quality data and how to start working with it. So if that's something you like to do, it is optional and there for you to try out. So in summary, this is Tutorial 1. We've gone through the expectations, the resources you can use to do it. Again, it's 1 to 3 type pages, and you're welcome to reach out over email. I know I highlighted this in the last video, but the syllabus is the place to find all of our emails. They're always up to date, and you'll be able to work with it there. So this is the way I would suggest you approach the assignment for Tutorial 1, and you can get started with that. So just as a side note, if I wanted to download that file, I could go to Class 2, and I could click on Tutorial Data here, download that data. All right, open it up, and I'll see a few things. I'll see lead bottle 1, 2, and 3, and some notes, and a sample ID. I'll see some removed samples here that were removed, and then comparing the Virginia Tech versus the Michigan Department of Environmental Quality. And so if you watch the video, it will become a little clearer what we're doing with this and why this is important. But in addition, if you don't want to watch the video, you can also just go to the modules page and go back to the assignment page. Now that we've downloaded the data, we can go to the first tutorial, download those instructions and primers if we haven't already. I'll just download it another time. And then open that up. And if on Windows, if I click and drag to the right, I can actually show all of my files and have them side by side like this, which is really nice. And then it says, okay, to start, let's look at the descriptive statistics. So one labeled Flint home samples and another labeled remove samples. I can see these here. And finally, one labeled Vermont versus MDEQ. So it says, starting on the Flint home samples tab, look for any values that seem extremely high or low, perhaps 999 or 000, as they may be codes from the person who took the data. Can you tell who collected this data based on the data set provided? Hint, scroll down. Do you detect any low data points? So the first thing I want to do is enable editing, because I do want to be able to actually edit this document. And I can see here that if I scroll down, oh, there's some information. Oh, the Flint Water Study Team at Virginia Tech. Now, as bad practice as it is to put your metadata at the end of an Excel sheet, and the reason why this is bad practice, because common statistical software such as R, Stata, SPSS, requires that you have only rows as observations and column as data points, and if you want to add separate values, you wouldn't want to put them in the same column. Because as you can see, this sample ID, which is in column A, is now also including important. Please note the detection limit of the ICP-MS at Virginia Tech is 1 part per billion, and that is not, in fact, the sample ID. So formatting these in these Excel sheets in this way can be bad for import into statistical software. So that's normally why we suggest against doing this. Nonetheless, this is important data to have in the spreadsheet, and I'm so glad they added it. I think that's great. So, starting on that Flint Home Samples tab, we look for any values that might seem very high or very low. We might want to think, and I'm not going to tell you exactly what these are, we might want to think about if we find low values or high values, what they may be. Are they codes? Sometimes 999 means no sample. What do you think that could be? Is there a way to figure that out? We learned who collected this data based on the data set provided. We note the reported detection limit of 1 part per billion of lead. Now, a detection limit is the limit of detectable concentration of an element in a sample. And ICP-MS stands for Inductively Coupled Plasma Mass Spectrophotometer. And it's totally okay if you don't know what that means, but more or less what you can think about is it takes a flame, an inductively coupled plasma, so the same material that is in suns, right? A plasma, it's a state, right? It takes a plasma and it aspirates a sample into that plasma. You can then look at the color change of that plasma and see what types of elements are in there. That's normally called AES, atomic emission spectrophotometry. You can take the remnants of that sample and pass that into a mass spectrophotometer that looks at the mass of those elements to give us even further information, not just the element itself, but we can get more information about that material that is available in that sample. So it's a really nice approach to be able to work with water in that way. And it's really great. It's probably one of the standard for metals work, as it has a very low detection rate. So we note the reported detection limit of 1 part per billion lead. Do you feel comfortable with this analysis, which, especially given your reading 2, which highlights the risks of low-level tap water exposure? Do you think it could be lower? Are there ways to get it down to something lower than parts per billion? Do you think that's important? Why or why not? That's one thing you could talk about. Next thing you want to do is use Excel or a LibreOffice program to generate the following statistics for each column. So in Excel, if I want to input a value in Excel, I can double click on it and it opens a editing session. I can type the equal sign and I can put in a command into Excel. You can use average with data inside to find the mean, median with data inside to find the median, standard deviation with data inside to find the standard deviation, and etc. So this kind of goes through. If you haven't used Excel before, you might be confused right now. I suggest you walk through the background video I give here if you've never used Excel. So we might want to compare the mean to the median. So we want to go to the Fluent Homes tab, and we want to create a new value. Maybe we'll call this mean bottle 1 and mean bottle 2. And what we want to do is go through and equal sign mean or average. Right? I note that I started to type average. I typed AVER, and then I pressed tab. This is called tab completion. It allows us to select certain values and auto-complete them, right? It's just like on your phone when you're texting and you want to auto-complete something and you click on the correct word. It's exactly like that, but we use tab to complete it. This is really common in this. So let's say I wanted to actually look across all bottles. Well, I can click and highlight, click and drag across these 3 values and my parenthesis, press enter, and it will autofill. And so this is mean all bottles. Let's say I want to look at the median of all bottles. So I can do the same thing. Median. Start the parentheses, highlight these 3 samples right here, and now I have the mean and the median. So we can compare the mean versus the median, and we can see when would we want to use one, when would we want to use another. You can see this link here. I'm just going to enable it so we can open it up. And this is a great website from Layered Statistics. It talks about measures of central tendency, one of which is a mean, the other of which is a median. You don't have to purchase this, although you're welcome to view this. This article is totally free to look at. And we can talk about when we might want to use a median versus a mode, and how that relates to water sampling. Finally, we can compare these data sets with the student's t-test. Now, one thing to note, you shouldn't use a t-test with this type of data in a actual sampling process, okay? We use a t-test for, in this case, as an example of types of analyses that you can do. However, a t-test is inappropriate, and it is not included in the EPA lead and copper rule. It is a violation of that rule to use the t-test. So you should really, really think about, well, in this case, with this data, it would be a violation to be using the t-test for this. We're doing it as an example for you to learn. We're not doing it so you can use it in the field, right? My suggestion is always to look at the guidelines posted in your region before you start sampling. Think about what regional environmental body has guidelines. You could always look at the US EPA, although maybe less so now that we're removing the lead and copper rule in the Clean Water Act. But you can always look at a lot of the sampling methods that have been developed by the EPA and some of the European protection agencies as great samples of how to do this type of thing. So, but if we wanted to do a t-test, we could do the very same thing. We could press the equal sign, type t-test, and we can put in 3 values. Array 1, the first set of data to compare. Array 2, the second set of data to compare. The tails, tails gives us some information about the directionality of the relationship, and then the type of relationship that we're testing for. And so we can talk about these a little bit, and there's some more information there, and we can kind of see this. The final thing to think about is that the EPA requires that no more than 10% of households that are tested have more than 15% or that have more than 15 parts per billion lead in their drinking water. That is one of their requirements. And so we see we had to remove some of these values for different reasons. And so we might ask, why were they removed? Is that appropriate? Why is that appropriate? Why is it not? And so we can talk about that. You know, they did not wait for 6-hour stagnation, used a different faucet for bottle on a different water supply, etc. And so this is the general approach to sampling water. We went through and calculated mean values here, and so we could compare these mean values by what's called visual inspection, by looking at them, or by actually doing statistics using that t-test. So if you have any questions, don't hesitate to reach out. I just wanted to go through this to make sure that even if you wanted to do this additional optional assignment, you would be able to do that. So thanks, everyone.